I see the reachability distances for 5 data points. Each number represents how far a point is from a previously processed point, considering the data point density. A higher number means that point is less densely connected to its neighbors. Think of it like this: higher numbers are less clustered. I'm analyzing optics clustering, a method used to group data points based on their density. Optics stands for ordering points to identify the clustering structure. It's a cool algorithm that's especially useful when you have clusters of varying densities. I'm working with a dataset that I'm analyzing with optics. The dataset is what we are going to group into clusters. I'm evaluating some statements regarding data point properties within the cluster analysis. Specifically, I'm determining which statements are true based on the reachability and predecessor information. I'm checking if point 0 is a core point. A core point has enough neighbors within its epsilon radius, a predefined distance. Point 0 has a reachability of 1.0. Since it is also a starting point, predecessor equals -1. It must be a core point. I'm examining whether point 1 is a core point directly reachable from point 0. The predecessor of point 1 is 0, indicating it's directly reachable from point 0. Its reachability, 1.5, is finite, suggesting it is also a core point. I'm determining if point 3 is a core point. Point 3 has a reachability of 1.2, which is finite. However, I need more information, the epsilon value, to definitively determine whether it's a core point or not. I can only conclude it's a possibly core point. I'm comparing the reachability distances of points 2 and 4. Point 2 has a reachability of 2.0, while point 4 has a reachability of 3.0. Therefore, point 4 has a higher reachability distance than point 2, making this statement false. This shows the reachability distances for 5 data points. A lower number means the point is more densely connected to its neighbors. For example, point 0 has a reachability distance of 1.0, while point 4 has a distance of 3.0, suggesting point 0 is more densely clustered. Think of it like this: a lower reachability means a point is easier to reach from its close neighbors. This array shows the predecessor of each point. The predecessor indicates from which point the algorithm reached the current point. A -1 means the point was a starting point, or considered noise. So, point 0 is a starting point. Point 1 was reached from point 0, point 2 was reached from point 1, point 3 was reached from itself, which may mean it's a cluster on its own, and point 4 was reached from point 1. I look at the predecessor array. Point 0 has a predecessor of -1, indicating that it's a starting point in the optics algorithm. This implies it's a core point because the algorithm started with it. A core point has enough nearby points within a specified radius. Point 1's predecessor is 0, meaning it's directly reachable from point 0. Its reachability distance, 1.5, is finite, suggesting it's also a core point. A core point has a finite reachability distance. Think of it like this: point 0 led me to point 1. That's direct reachability. Point 3 has a reachability of 1.2. This is a finite value. Its predecessor is 3. However, without knowing the epsilon parameter used in the optics algorithm, I can't definitively say whether point 3 is a core point. More info is needed. I need a little more help here. Point 0 is a core point. I have confirmed this based on the analysis of the predecessor array and the fact that it's a starting point in optics. Point 2 does not have a higher reachability distance than point 4. Point 4's reachability, 3.0, is higher than point 2's, 2.0. I compare the numbers directly from the reachability array. Point 1 is a core point and directly reachable from point 0, as its predecessor is 0. This is directly observable from the given data. Based on the information I have, this statement is likely true. Point 3 has a finite reachability distance. However, I can't say for sure without the epsilon value. This is a true statement. Point 2 has a lower reachability distance, 2.0, than point 4, 3.0. I see that clearly from the array. I'm analyzing data points using the optics clustering algorithm. This algorithm helps group similar data points together based on their density. This array shows the reachability distance for each data point. A lower reachability distance means a point is more densely surrounded by neighbors. For example, point 0 has a reachability distance of 1.0, the lowest value in this list. This array shows the predecessor of each point in the optics algorithm. A value of -1 means the point is a starting point. For example, point 0 is the first point considered, -1. Other values indicate that point was reached from the indicated predecessor. For example, point 1's predecessor is point 0, showing direct connectivity. I'm examining whether point 3 is a core point. Point 3's reachability distance of 1.2 suggests it might be a core point because it's relatively low. However, to be certain, I need to know the epsilon, EPS, value used in the algorithm, which defines the neighborhood radius. A lower reachability distance usually means a point is more densely surrounded by neighbors. I'm checking if point 1 is a core point and directly connected to point 0. Point 1's predecessor is 0, confirming direct connectivity from point 0. The reachability distance of 1.5 is relatively small, suggesting point 1 is a core point. I'm determining if point 0 is a core point. Because point 0 has a predecessor of -1, it is a starting point and it has a finite reachability. That means it's a core point. In this context, I'm comparing the reachability distances of point 2 and point 4. Point 2 has a reachability distance of 2.0, while point 4 has a distance of 3.0. Thus, point 4 has a higher reachability distance. I'm analyzing a data point quiz related to optics clustering, a density-based clustering algorithm. I will examine the reachability and predecessor arrays to understand the data point's characteristics. This array shows the reachability distances for 5 data points. A lower number means a point is more densely connected to its neighbors. For example, point 0 has a reachability distance of 1.0, which is lower than the reachability distance of point 4, which is 3.0. This array shows the predecessor of each data point. The predecessor indicates the point from which the current point was reached during the optics algorithm. A -1 means the point is the starting point of a cluster, or noise. For example, point 0's predecessor is -1, indicating that it is a starting point or a noise point. Point 1's predecessor is 0, meaning that point 0 was used to reach point 1. Here, I have two arrays, reachability and predecessor. They're the output of an optics clustering algorithm, and I'll use them to answer questions about the data points. I need to evaluate multiple statements based on the reachability and predecessor arrays, determining which are true and which are false concerning the characteristics of the data points within the optics algorithm's context. The core concept is to understand if a point is a core point in optics clustering. A core point is a point that is dense enough and its reachability distance is finite and less than epsilon. I'll explain the optics algorithm's workflow in simple terms. It starts by inputting data points, then calculates the density around each point. Next, it computes reachability distances and identifies predecessors. Finally, it outputs the reachability and predecessor arrays. These arrays are essential for understanding the clustering results. First step in optics is to provide input data points. Second, optics algorithm calculates the density around each data point. Next, the algorithm computes the reachability distance for every point, considering its density and distance to already processed points. Then, the algorithm determines the predecessor of each data point, which represents the point from which it was reached during the processing. Finally, the optics algorithm generates the reachability and predecessor arrays as the output. These arrays contain essential information for understanding the clustering structure obtained from optics. I'm analyzing data using the optics clustering algorithm. Optics stands for ordering points to identify the clustering structure. It's a powerful tool for finding clusters in data, especially when dealing with datasets that have varying densities. I have a dataset that I'm applying the optics algorithm to. The goal is to identify clusters within this dataset based on the density of points. It's like finding hidden communities in a large social network. This array shows the reachability distance for each point. The reachability distance measures how far a point is from a previously processed point, considering the density of the points around it. A lower reachability distance means the point is closer to its neighbors, suggesting higher density in that region. For example, point 0 has a reachability of 1.0, while point 4 has a reachability of 3.0. meaning point 4 is less densely connected to its neighbors compared to point 0. Think of it like this. A lower reachability distance means you can easily reach that point from others nearby. This array indicates the predecessor of each point in the optics algorithm. The predecessor is the point from which the current point was reached. A value of -1 indicates a starting point, a core point in the cluster's seed. Point 1, for instance, has a predecessor of 0, meaning point 0 was used to reach point 1, suggesting direct connectivity. This is a function from the sklearn library in Python. I use this function to perform optics clustering, and it provides me with the reachability and predecessor arrays. I see that point 0 has a predecessor of -1, which indicates it's a starting point, or a noise point. Since it's a starting point and has a reachability value of 1.0, indicating it is surrounded by enough neighbors within the epsilon radius, then it must be a core point. Point 1's predecessor is 0, meaning it's directly reachable from point 0. Also, its reachability distance is 1.5, implying it's also a core point because it has a finite reachability distance. Point 3 has a reachability distance of 1.2 and a predecessor of 3. While its reachability is finite, suggesting it could be a core point, I can't definitively say without knowing the specific parameters used for the optics algorithm, especially the epsilon value. I'm analyzing a dataset using optics, a powerful clustering algorithm. It helps us find clusters in data that might have varying densities. Think of it like grouping similar items together, even if some groups are more tightly packed than others. The dataset is the collection of data points I'm working with for the optics clustering algorithm. This array shows the reachability distances for each data point. A lower reachability distance means a point is more densely surrounded by its neighbors. For example, point 0 has a reachability distance of 1.0, the lowest among the 5 points. Point 4 has the highest reachability distance, indicating that point is less densely connected to its neighbors. This array tells me the order in which optics processed the points. A -1 means the point was a starting point, or a seed, for a cluster. For instance, point 0 has a -1 predecessor, meaning it's a starting point. Other positive values tell me which point was used to reach the current point, showing connections and cluster paths. I'm checking if point 0 is a core point. It is a core point because it's a starting point, predecessor equals -1, and has a finite reachability distance, 1.0. Core points are densely populated regions in the dataset. I'm looking at point 1. The predecessor is 0, meaning it's directly reachable from point 0. It's also a core point because it has a finite reachability distance, 1.5, indicating it's surrounded by other points. This statement compares the reachability distances of point 2, 2.0, and point 4, 3.0. Point 4 has a higher reachability distance, so this statement is false. I'm analyzing if point 3 is a core point. It has a finite reachability distance, 1.2, and predecessor 3. Whether it's a core point or not truly depends on the epsilon parameter used in optics that I don't have the information for here. So, I can't say for sure.